Good morning, everyone, and welcome to today's EnRoute webinar. My name is Bennett. I'll be the moderator for today. Our presenter is Aaron Clapp, Application Specialist at SAi. He knows everything there is to know about EnRoute, and today he'll be walking us through some of the unique specialty toolpaths that EnRoute has for you to use. After the presentation, we'll be able to answer any questions you have either about toolpaths or any other EnRoute topics, so feel free to put those questions in the chat and we'll answer as many as we can. We are recording the webinar as always, so if you want to review anything that Aaron discusses, we'll be sending you all the link here this afternoon, so look out for that. And that's about it for me, so I'll turn it over to Aaron.
All right, sounds good. So today we're just kind of going to go over some of the lesser common toolpaths that sometimes I don't get to see as often. Some of them are newer to EnRoute 7 than others. But the first one we will kind of want to look at is the drag knife. The drag knife was a new tool that was added in EnRoute 7, and it works with a very specific style of tool. So if you've ever used one of these tools, this is one manufacturer that makes them. Donic is one of the companies that makes them, but they have essentially what this is it's a razor blade that rotates, has a rotation axis here in the center. So this is not for a tangential knife or anything like that. This is mainly for these kinds of tools that would fit inside of your collet with a spindle speed of 0. Then you'd set them up that way. So that style of tool. Now, again, there's several manufacturers that make tools that are like that. Donic's not the only one, but that's kind of the first one that kind of comes to mind. So let's start by adding some text here. Then we'll start doing some tool pathing and kind of show everyone the drag knife. All right, so I'm going to convert those to curves. And let's go to our tool library. And the first thing you're going to need to do is we will need to set up a drag knife tool. I have a default knife set up here, but we'll just go ahead and hit new. You'll select knife, and these are our parameters here. So the D1 is going to be the distance between your center point or your rotation point and the tip of the blade. So this is going to be kind of offset depending on where you're at. I don't know that I didn't really keep that. I closed that window, but typically your axis of rotation is going to be slightly different from where the tip actually is. And so that's going to be important to know. So this angle or this setting is very crucial in terms of setting this up. We want to make sure that we have this correct. And this is the center rotation axis. That's what this is. So this is the part that actually connects to your spindle and where the center of the blade kind of rotates at. Typically, that's never, usually it's not right at the tip, although it could be, but typically it's offset from the center of the blade or from the tip of the blade. Then we obviously have our height, which that's kind of self-explanatory. That's kind of an easy one to measure. And then the angle at which that blade is sitting. So depending on the kind of tool that you have, you could probably set that at a different angle, but most of the time that would be set at like 45 degrees. That's your typical angle for these as well. So that's kind of how you're going to set these up. And again, like I said, the main thing here is this D1. If I increase this or decrease this, you can kind of see how that moves in and out based on where that is in position. So this is going to be something you'll need to measure. A lot of the manufacturers that make those drag knife style tools will probably have that kind of information available to you as well. So once you've created it, it's basically as simple as creating a routing offset. It acts very similar in terms of how a routing offset performs. put this in here. So we've got all kinds of different settings in here for if we want the software to lift in the corner, or if we want it to create a radius corner. This all kind of depends on what you want it to do in the corners. And let's just hit OK to kind of see what it does, because these toolpaths are going to look a little bit different from what you're typically going to see. So you'll see here in the corner that it's going to move past the endpoint, and this is to basically accommodate for the offset between the center of the tool, the donic tool, and the knife where it actually is. And so it's having to move past here, and then it's swiveling to put the orientation of the blade in the correct position before it moves forward. You're also going to notice that, and it's not real obvious here, but if we zoom in here, you're going to notice different things about the toolpath. So as it's moving, it is the EnRoute software is actually compensating for deflection and for the offset of the bit. So you can kind of see here in several different places where it gets farther away and then it gets closer. So now we have a spot right here where it's a little closer. What this is basically doing is the more the bit, or the knife in this case, is curving along, the greater the radius, the farther out it has to offset itself, so that you make sure that that tip of that blade is always in the correct location. So that's just kind of one thing that you'll notice about this toolpath that may look a little strange, is that you've got these little tabs kind of sticking out here, and that your toolpaths may not always be right on the line, but that's okay, because EnRoute is doing that mathematical calculation for you to avoid making sure that it stays within the line that we want it to cut, and it prevents that deflection that might actually happen. If we edit this toolpath, again, we can do other things here, like we can create radius corners if we would prefer it to do that. And it changes that up just a little bit. Let's delete the toolpath here and reapply it. We can also do radius corners on outside corners. So let's just assign a radius here. We didn't do that. So let's do 0.2, so it's kind of obvious. So instead of those little tags, now it's just going to create a radius in order to create a smoother transition between there. So depending on what you're doing and depending on how you're handling that, you might want to do radiuses instead. So this is just kind of an over-exaggerated example, but you can kind of see here where it's cutting off the edge in order to prevent or avoid some of those cases where the drag knife is going to get in this corner and then it's going to dig in the material, because even with the drag knife, you're always going to have that rotation of the blade happening as you drag it. And when you get into a corner like that, it can really cause some issues. And if it's causing tearing or other problems, perhaps applying a small radius to avoid that little corner would be a better option. So again, this is a toolpath that is new to EnRoute now, and that can be added in to any of your workflows. This is, again, particularly useful if you're cutting through things like vinyl, if you're doing the print and cut style workflow where you're printing something and then bringing it onto a machine and cutting it out. This would work well with that. Or a lot of times when you're cutting things like cardboard or plastics or something like that that might not necessarily need a bit and would work better with a knife, this might be your good option there. So that's drag knife toolpathing in EnRoute 7. Now, another one that is kind of different, and this is one that I don't really get seen that often, but I think it's kind of overlooked in terms of what it can provide and kind of the unique surfaces that you can create with it. Now, I know we've been talking a lot about 3D and surfaces and things like that in the last couple of webinars. And one of the things that I always tell people is that if you can accomplish another 3D effect without having to use 3D, you're actually way better off. And so what we're going to do is we're going to actually apply a island fill here. We're going to use 3/8 ball end mill. And what I'm going to do is, we don't need to go that deep. That's fine. I'm going to change the fill. Okay, I want to make sure my fill was set to 70% in this particular case. And I'm going to hit apply. Nothing special here, just kind of an ordinary toolpath, right? Nothing overly special. But then what we're going to do is we're going to apply some distortion to it. So if we go to Edit Toolpath under the Toolpaths menu, and I click Distort Toolpaths, here I can start to play with some of these settings that are very similar to the settings that you might find in rapid texture. So you've got a horizontal amplitude and a vertical amplitude. Horizontal is obviously going to be, vertical is going to be in your up and down, and horizontal is going to be your axis this way. And then your wavelength, this is going to be control how long the waves are, and then how much jitter you want to apply. Again, this is kind of a randomness kind of thing here that we can add. So I can hit preview and kind of see what's going to happen here. So that all the pink lines are going to show me what's going to happen. If I increase something, let's say we go to 0.5 on the jitter, you can see it kind of goes a little more crazy on some of that. I can also, let's go back to 0.2, and let's try make the wavelength longer. So let's try going with 4.2. Let's kind of preview that and see what it does. So now you can see it's creating some noise, but it's a lot more longer waveform. So you can kind of play around with some of this and kind of see what happens. We're going to go back to what it was. I believe it's either 1 or 2. I think it was 1. I'm going to create that there. And I'm just going to hit apply. And basically what it does here is it takes the existing toolpaths and kind of twists them and distorts them in kind of a crazy way. Now, if we go to preview this, and I'm going to draw myself a little square here, just a boundary, so that I can, when I go to my Simulate 3D, I can use this option, select contours as a mask. So I'm going to use that little square as a mask so I can bump up the resolution without getting too big in the megabytes. What that does is, instead of processing the whole plate, it only processes this little area right here, because I don't need to preview the whole plate. I need to just preview this area. So that allows me to stay lower on the megabytes. So if I uncheck that option, look at how it jumps up. This now becomes an extremely difficult thing to process. So using that allows you to bump up the resolution quite a bit, much better quality preview, but not sacrificing a ton of, processing time and things like that. So that's just a little tip there. And oh, you know what? I forgot to add. We gotta change one thing here. We need to go here. I'm gonna add some thickness here to my material. There we go. That's better. I'll go up here. That cut was going a little too deep there. All right, so here we go. So again, nothing super crazy, kind of a different, we're just using a ball end mill, and we've been able to reproduce something that's very, very similar to something that you'd find in a rapid texture, or even like a 3D texture. So this would be very similar to the cells texture inside of rapid texture. So, real easy, nothing crazy. Delete our toolpath. Let's apply another one. This time, let's do a conic tool and see what we can get. Let's throw that in there. We're down 1/4 inch. Let's set up our fill. It may not like this. We may need to use a different bit for this. Oh, okay, it did let me do it. All right, great. Let's see here. Now we'll go to our edit toolpaths. We'll distort these a little bit. Why don't we just apply the same distortion and then kind of preview that and see what we get. I'm not quite sure what we'll get here. This will be interesting to see. But the idea is now we can create some kind of custom looking patterns and things like that that don't require us to get too deep into 3D because 3D takes a lot more time to process. This is just a 2D toolpath, and now this is kind of a crazy aggressive texture, but it kind of has a unique look, right? So again, in different use case scenarios, this could be used if you take this and perhaps maybe you give it a slight change in depth so that we're not cutting quite so deep. You can get kind of like an etched texture that has a little bit of randomness to it, things like that. You can also do this with the other toolpaths like a routing offset, any of your island or spiral fills, your hatch fill, engrave toolpaths. They can all take this toolpath distortion. So kind of a unique distortion toolpath. It gives the ability to kind of create a little bit of randomness in your toolpathing for creating nice backgrounds for signs and different things like that. This might actually be a good option for creating kind of like maybe like a sandblasted type texture with the tip of like an engrave tool or something like that, kind of creating some like little wood textures or striations or something like that. So this would be a good option. And again, the benefit here is that if you play around with this, you can kind of get some neat things that are not tied to 3D, which this cut would take significantly less time. So that's kind of the benefit here, is if you have to do 3D, you have to do 3D. But if you can get away with not doing it, you'll save yourself some time. So one of the other things that we want to kind of quickly look at is let's go back to here and let's talk about projecting toolpaths to a plane. Now, projecting toolpaths to a plane is kind of an interesting concept in terms of rotating and changing the angles of a toolpath. I want to go back here and delete this. I'm going to go back to our other ball nose here. And let's just do 0.2. I think we did our overlap is still the same. Oh, let's do... Yeah, let's go back to 70. All right, and then let's do our distortion again. Actually, yeah, let's just do our distortion again just because I want to see that effect, and we'll apply it. All right, so one thing that we're going to look at is from the top view. We're going to zoom in here, and we can kind of see how that varies up and down in the Z a little bit, right? That was our vertical. So our horizontal distortion, and then our vertical distortion is here in the Z-axis. So what I'm going to do now is I'm going to say toolpaths. Well, first I have to select it. So select my toolpath, go to toolpaths, and then say edit, and I'm going to say project toolpaths. So basically what this allows me to do is project a toolpath to a different plane. So by default, it's going to look like this, where angle is selected, apply across selection is unselected. And then it gives me an option for an angle or a height. I like to do by height just because it makes a little more sense to me, because I'm a little more number based that way because I know how thick my material is. But you could do this as an angle if you have a particular draft angle that you need to apply it to, not necessarily depth or height. You can do that. And I just choose the angle with rotation. So if I choose rotation angle in this corner on the left, it's going to anchor this side and it's going to rotate down here. So basically this corner down here is going to get anchored and this side here is going to get pulled down. So if I do that, let's just say by 0.25 inches, And I need to select that, height, 0.25 inches, apply. You can see there where it's now angled my toolpath down deeper into the material. So again, this is kind of an interesting concept because then you can create all kinds of unique things. Some of the use case scenarios I've run into while using this is, for example, creating some kind of a sink where it has slots that are shallow on one side and deeper on the other. And they're just, all they are is just open contours with an engraved toolpath on it, and it slopes down into the material. So that's kind of a neat use case scenario for that. Or, creating some kind of depth that goes from one side to another. So let's just kind of preview this so we can kind of look at it. And it'll be a little bit subtle here, but we'll be able to see it. If we look at it from the side here, we can kind of see how we're right at the top here. And as we progress along, it's getting deeper and deeper into the material. So we've kind of made that transition down. And it doesn't really affect the way that the toolpath or the way that the texture looks. It just has a nice angle to it. So this is a really good way to do that. This might actually also be a really good way to create several pieces that slant towards the middle like this. And when you combine them, it kind of creates a slant that kind of ends up in the middle from all four sides. Let's look at another option here that's within this project toolpath that might come in handy. Let's delete this. And we're going to go into our material real quick here. I'm going to change this to, well, we'll leave it at that. We'll leave it at that for now. I think we'll be okay. Let's do some text. I'm going to grab an ER font here, which is just one of our real basic single stroke fonts. There we go. Yeah, let's grab that guy and put it in the middle. Okay, so now what I want to do is I'm going to grab this whole thing and we're going to throw, let's just throw an engraving toolpath on here. And let's clear that off and let's do, actually, you know what? Let's just keep that on there. Let's just keep this tool that I was using before and click OK. So nothing special, right? This is just a really basic toolpath. Everybody knows how to do this. But what I'm going to do now is I can do several different things. So if I go to my project toolpath, if I say project by height, and let's do 0.5 inches this time, and I hit apply, look at what happens over here in the front view. You notice that each letter now has a slant to it. So I could kind of get a unique effect like that. If that's not what I'm looking for, though, I can hit undo, and I can check this option right here, apply across selection. And if I do that, it applies it to the total selection. So now each letter is not getting that 1/2 inch dive every single time. The whole thing is getting the 1/2 inch cut. So again, if we were to preview this and kind of see what this looks like, let's bump that up a little bit so it's got a better preview. You kind of see how it's definitely getting deeper as it goes along. So we're starting real shallow here, and then we're progressively getting deeper as the cut goes along and getting down to the 7 here where it's the deepest point. So kind of a unique effect, a unique little tool. Again, this is, you can do this for all sorts of different things. For example, if we go back to our cuts where, let's go and draw ourselves another little rectangle here. Actually, let's just use this one. And instead of applying such a crazy toolpath, let's just create a hatch fill with an end mill. And we'll use a fairly large one, maybe a 1/2 inch. We're going to cut this 0.25 inches down in, and let's just do a little bit more than 50. Let's do 60% overlap here just to be safe. And then let's just project our toolpath. Let's do it the other way this time. When we look at that, we can see that our toolpath is cutting down at a slant. And again, this is kind of a little bit difficult to see. Actually, you know what we could do? Let's go back here. Let's change our preview. Let's just change that just like that so that we're actually cutting it in half so we can see the cross section. We'll just do that real quick. It'll kind of give us a nice little, oops, I forgot to select my contour. Got to do that first. Otherwise that doesn't work. There we go. There we go. So we can kind of see the cross section on that. So again, this is something that you can also accomplish in 3D. If you needed a wedge shape, you could do that in 3D. Or why not just use a toolpath? Or instead of going to all the effort in creating a three-dimensional object, using sweep to rails and doing all that nonsense to create this. I mean, that's one way of doing it, yes. But if you can do this, this is a million times faster. So you're using an end mill at 60% or 50% overlap, whatever you want that overlap to be, versus having to use a small end mill at like 80 or 90% overlap, and toolpathing it in 3D. So kind of a neat, unique, you're creating wedge shapes in different angles like this for different cuts and different effects. Very, very, very useful tool. I think this is one of those underrated toolpaths that doesn't get used as often because it's kind of mysterious or it's kind of hidden down in the menus a little bit. It doesn't get used very often, but this is very, very powerful, very good tool to use. And then I think we'll wrap up today with the option for slots. And I kind of want to just mention this one again because I think it doesn't get used as often as maybe as it should. But the slots toolpath is kind of a unique toolpath in that it allows you to do keyhole kind of toolpaths where you need to plunge in, move, and then retract out of the same location. So I'm going to just throw an open contour on screen here. This is going to be the contour that we're going to apply this to. You don't have to have a contour, and you don't have to select the contour either. And what I'm going to do is I'm going to have my snap to segment endpoints turned on. I'm going to go to Toolpaths, and we're going to go to, let's see here, Toolpaths, where's my slot tool? There it is, under Specialty, Slots. I just have a generic tool here, just an 1/8 inch end mill. But what I can do is I can either tell, and by default, these would all be 0. They would look like this. So we can, remain consistent here. But we've got some options. I can either tell to start in a specific XY coordinate and end at a specific XY coordinate, or I can do it by graphic. The nice thing about this toolpath is that it also allows me, this is the only toolpath that allows you to do back and forth movement in terms of retracting in the same place that, apart from a drill, of course, but entering and retracting from the same location. So I can hit back and forth. And when I hit OK, I'm going to get this cursor because I chose by graphic. And this might be helpful if you have like a drawing of a cabinet part that already exists and that has, there's 2 typical methods for dados and stuff like that. But you might run into a circumstance where you have a line where a toolpath is intended to be placed. And so because I have my option selected here, you can kind of see this little red dot that keeps following my cursor. If I put it up close, you can kind of see it's attached itself there. I'm going to left click and hold and drag. I'm going to use my mouse wheel to kind of scroll in here. I'm going to just snap it to the end of that line, just like that. And there I have my slots toolpath. Pretty basic, but if we go to our simulate ortho, what we can do here is we can kind of see the effect. And again, this is something that I think is going to be used in a lot of unique style circumstances, but it's good to know that, you know, this option is available to you. So you'll see our tool kind of approaching, plunge, make the cut, come back, and then retract out of the same hole. This is useful for all sorts of things. I've seen people use it for creating keyhole style cuts where you have a bit that can cut down and then you want it to move forward and then come back. Or perhaps maybe you're doing some kind of a cut in the side of a piece of material that for like a door or something that's going to have these little tabs so that when you glue them together they meet. That would be really useful to have a tool path that would retract it, go in and then come back out, because you want it, you're going to probably be cutting it from the side of the material, right? So you're going to come in from the side and then retract back out. Or perhaps maybe you want to cut a slot along the side of a door or something like that. So you come in from the side, you have it cut in, you go all the way the length of the material, and maybe you have it come back and pull back out in the same place. So slot toolpath could be useful for all sorts of different things. Again, one of those toolpaths that I think is kind of underrated. It doesn't get a whole lot of use because it does kind of have a niche market out there. But if you know that it's there and you know it has that ability, that might be pretty useful for you as well. So just as kind of a extra throw in here, there are a couple other toolpaths that I wanted to kind of mention for the fabrication side of things. They aren't really specialty toolpaths, but I always like to mention them because they might get overlooked. But we now have Kerf marking and Kerf fill toolpaths. We've kind of expanded the Kerf compensation for lasers, plasmas, water jets. Typically, we just had the Kerf compensation and open offset contour. Now we've added a couple new options that allow you just to customize your toolpaths for that. So I can now do a island fill with my water jet or whatever if I really want to. And the nice thing about this is that the options have all been stripped down to the essentials to what you need. You could do it before with the island fill, but there was a lot of other settings there that were kind of mixed in there that were more routing based. And so it was very difficult to kind of determine what was going on. Now the Kerf fill and the Kerf marking, which would be kind of like an engrave toolpath right down the middle of the line. So if you've got open contour text or open line single stroke fonts or whatever it is that you want, now Kerf marking will apply toolpath. Again, stripped down settings that are only the settings that apply to plasmas and that kind of thing are there. And then it applies directly to the line. So just some things to think of as well if you're using those sorts of toolpaths and you have a plasma or a water jet. Those are some new toolpaths that have also been added in EnRoute 7 to kind of build up the toolpathing options. Any questions on these kind of tools? I know they're a little bit unique and they have kind of different use case scenarios, but I think you can always find some use for some unique toolpaths.
Not seeing any questions at the moment, but I will say, again, if you do come up with a question that you're not thinking of now, you can always put that question in the comments of the recording of this video on YouTube, and we can answer the question there or refer you to a place where you can't get the answer. But are there any questions that you can think of now that Aaron could answer live here?
While we're waiting for that, I will mention if any of you have not if any of you are running 7, one of the things that I would probably suggest is check your help menu and click help and about, and check your version. There is a new version out, version 7.0.0.1109. So if you haven't gotten that upgrade yet, I would do so. It has a lot of bug fixes to things like ATP and a bunch of other stuff, some crashing things and other random fixes. So if you haven't gotten to that yet, I would highly recommend it. If you do call tech support or you do decide to download and install, I would just recommend that you just install it on a new folder. And then you can always use your help menu and use the load settings. So if you overwrite your previous install, unfortunately, the installer has no regard for your previous settings. So it'll probably just wipe you clean. So don't do that. That's a no good option. Install it in a new folder, call it EnRoute new or EnRoute 7.1 or call it whatever you want. Just don't call it the same thing. And you'll see it in the installer. It'll ask you what you'd like the folder name to be. Just change it to EnRoute 7 new, and then it'll install its own directory. And then you can, that way, because we all know we got to do work, right? And we can't be down. So the important thing is if you install in a new directory, your old install is still there and it will still work. And then you can come into the new version, hit load settings, and then you could just navigate to the version that you need to select your settings. So if you're coming from 5 or from 6 or wherever you're coming from, you can select that folder, hit OK. Hit OK. That'll import all of your tool library, your strategies, your plan templates, your driver, your preferences, everything will come in. Your ATP settings, it'll all come over. And so it'll be a real seamless transition. So that's just something I would recommend. If you haven't gotten it yet, do that. That'll be a really good thing to do. We definitely recommend that update. So.
Okay, I've got a question from Bill here. Is there a rule of thumb for 3D Simulate as far as the number of megabytes that won't break the bank?
That's a good question. No, there isn't. And that's kind of a tricky one. So that's one of the reasons I will say this. EnRoute 6, or it's EnRoute 7 has the new 64-bit processing in it. So you are going to be much better in EnRoute 7 versus older versions, because I know older versions did have that issue. So if you have more RAM, so if you have 32 gigs of RAM, it's going to start using more of that, whereas before it could only use 4. So there's that. It uses our processes a little bit better, so everything draws and renders quicker. I've noticed a huge difference in my laptop, improvement in that area. But the biggest thing is going to be, do you need to preview the whole thing? And many times the answer to that is no. Sometimes it's nice to see the overall picture. And that's probably where, when you go to preview something, let's see if I can go back to one of my previous toolpaths here, just so that, there we go, just so that when I click on simulate. So I'm going to select that. You can simulate the whole thing, but you're going to have to scale this back quite a bit. I would say typically if I'm processing depending on the power of your computer, if your computer's weaker and you kind of know that, then maybe you back this off quite a bit. If I went for 25 megabytes right off the bat on the full sheet, you can already see I'm just moving things around and it's taking a little while to process. So even with a very powerful computer, I'm okay, and I'm still having some issues with processing. So that's where I would say, if you can, find out what you really need to preview. If there's something that you really need to see to verify that it's actually cutting correctly, you can always go back and forth a little bit and preview different parts of the file. So, perhaps maybe you want to preview this little section up here and just see how that cuts. You do that, and you can do this a couple different times. Now, obviously, it's not the most ideal, but this allows you to bump up your resolution much higher. So now we're running a resolution of 184, which is really high, but I'm only having to process a small piece here. So the processing works much faster. So now you can see when I move it around, it's instant. So I can go much higher on my processing if I selectively choose which areas I need to process. So no, there's no real magic number. It's kind of more of a evaluate your situation and go from there. In EnRoute 6, I would say that this is almost a necessity. Like I would very few times render the entire plate unless I had the resolution set way down, just so that I could get an overall view just real quick. But if I had to look at anything in detail, I would definitely be using the contour option to vastly reduce the amount that it takes. So, but that would be another plug for EnRoute 7 if you haven't gotten EnRoute 7 yet. And if you do, then sweet.
Yeah, and just a quick follow-up from him. He's asking, what's the corporate policy for bug fixes?
So with EnRoute 6, all bug fixes are, so whatever the software is kind of what it is. So at this point, we don't change anything on those older versions. So it would just be, kind of what it is what it is. Yeah. Most of the things like new, because I know like new features and things like import filters and drivers and things like that typically are tied to the new version, mainly just because that's the version we're spending all the time on. And if we spent a bunch of time going back and fixing older versions too much, then we would never finish our newer versions. So we try and do bug fixes for as long as we can on the current version. So as long as the current version is active, we do bug fixes as much as possible until the next version releases. And then we kind of stop unless it's like a critical, the software is falling apart kind of issue, then we would go back. But for the most part, that kind of stuff doesn't come up very often. But
yeah, and that's one of the main benefits of a subscription, other than it being more affordable. You're always getting those updates and bug fixes no matter what. You're paying the same amount every month or quarterly or yearly or whatever, and you're always on the latest version. You don't have to worry about having an out of date version.
Trying to think what the latest version of 6 is. It's 6.1.70, I think. 70, I think. Yeah, something like that.
Okay, any other questions for Aaron before we close it out? Oh, got another question from Bill here. Back to the ramping wedge cut we were looking at, do you really end up with a smooth surface? It seems like there would be ridges whose widths would be determined by the overlap.
If you're using a ball end mill, yes. If you're typically using a regular end mill, you probably still would run into a little bit of that, but that's where you'd probably want to increase the overlap just slightly. Normally it's at 50%, and I believe at 50% you probably would run into some of that. So you'd want to increase the overlap at least 10 to 20%, I would imagine. You may still run into a little bit of that, but the amount of time, depending on the material, the amount of time that you would save cutting it like that versus cutting in 3D would be so much more that you could just sand it or even run it at like 90% overlap or something like that. I mean, at that point, you're almost doing the same thing as a 3D. But if you're doing it like 60, 70% overlap, you're probably saving yourself a lot of time versus doing it as a slant. Plus, it kind of gives you the option. This is another option that's also available in your lower tier versions of EnRoute. So if you have EnRoute Plus, that option is available, whereas you might not even have access to 3D if you run EnRoute Plus. So if you want to do something that's like that and don't have 3D EnRoute Pro, then that would be a good alternative as well. So if you're familiar with doing 3D and it's something that you are already familiar with and you like it, you can get good results the other way, just doing it 3D. This is just a secondary option for something that needs to just be done quick versus efficiency versus 3D. Because once you get into 3D, it becomes more complicated.
Okay, not seeing any more questions here. Thanks, Aaron, for answering those ones and for showing us around those unique toolpaths today. We'll go ahead and close it out. Thank you all for joining us for this EnRoute webinar. Our next EnRoute webinar will be on how to use and what the differences are between strategies, plans, and templates. That'll be on November 15th, and we hope to see you there. We'll have the link to sign up for that in the follow-up email that you'll receive later today. Make sure you subscribe to our newsletter so you won't miss out on any webinars or other announcements, and you can sign up for that on our website. Thanks again for attending. We hope you learned something, and we'll see you next time.